Okay, just think about what your computer's doing right this second. You've probably got music playing, you're typing something up, maybe you have a browser open with like a million tabs. It all just works, right? So seamless. But underneath all that, it's actually a world of controlled chaos. And it's all being run by this invisible, totally unsung hero. Have you never stopped to wonder what actually happens when you click on an icon? In that tiny fraction of a second between your mouse click and a program magically appearing on screen? How does it all juggle everything at once without just crashing into a massive digital traffic jam? Well, it's definitely not magic. It's the tireless, nonstop work of a master manager, a piece of software that is so fundamental, so absolutely essential that without it, your computer would be nothing more than a really, really expensive paperweight. Yep, we're talking about the operating system. So what is it really? Well, at its heart, the OS is the ultimate middleman. It's the bridge between you and all the physical bits and pieces of your computer. The processor, the memory, the hard drive. Its main job, its whole reason for being, is to manage all that stuff so you don't have to, and to make your life a whole lot easier. So how in the world does it do all that? Well, the absolute best way to wrap your head around it is with an analogy. I want you to think of your computer as this huge, bustling city. And every single program, every file, every mouse click, that's a person, or a building, or a car. And the operating system? Well, that's the all-powerful city manager, the one making sure the entire metropolis doesn't descend into chaos. All right, so first things first for our city manager, managing the population. And in our digital city, the citizens are all the different programs and apps that you have running. Think about it. You open up your web browser. Boom, that's one citizen. You fire up your music player. That's another citizen. And every single one of them is demanding something. They want resources, they want access to the city's infrastructure, a place to do their job. They all want the attention of the city's main engine. And just like in a real city, every citizen has a life cycle. The OS manages this entire journey from start to finish. It decides when a new program, or new citizen, arrives. It knows when they're ready and just waiting for permission to work, that's CPU time. It manages them while they're running and actually doing their job. And, really importantly, it knows when to tell a citizen to take a break, to put them in a waiting state, maybe because they're waiting for a file from the hard drive. That frees up resources so another citizen can have their turn. And finally, it handles when they're all done and terminated, leaving the city. And hey, not all citizens are created equal, right? Some are what we call CPU-bound. Think of them like quiet scholars who just need to lock themselves in the library, the CPU, for long, long stretches to get their work done. Then you have the IO-bound citizens. These guys are like busy couriers, constantly running around town, picking things up, dropping things off, lots of short little tasks. The genius of the city manager, our OS, is that it has to create a schedule that's fair to both. So the scholar gets their deep thinking time, but the couriers also get to keep the city's commerce moving. It's a heck of a balancing act. Okay, so our city manager is juggling all these citizens. But that's not all. It also has to manage the city's real estate. And in the world of a computer, that land, that's your memory. Right, because there's only so much physical space, your RAM, to go around. It's a finite resource. So the OS has to put on its zoning board hat and start carefully handing out plots of land to every citizen, every process that needs a place to set up shop. And the OS uses this really clever trick to do it. You see, every program, every citizen, thinks it lives at a simple, easy-to-remember address, like just my house. That's what we call the logical address. But the thing is, the OS knows the actual, nitty-gritty address on the city grid, the physical address, like Lot 7, Block B. It handles all the translation between the two behind the scenes, so the program never has to worry about where it really is. Pretty smart, huh? But here is where things get a little tricky. Over time, as citizens move in and out, a problem starts to pop up. You end up with all these little empty lots scattered all over the city. Now, you might have enough total empty space to build a huge new skyscraper, but none of the individual plots are big enough to actually build on. In the tech world, we call this external fragmentation. So what does our brilliant city manager do? It orders a city-wide reshuffle. It's a process called compaction. The OS carefully shuffles all the existing properties, pushing them together to get rid of all those little useless gaps. And what you're left with is one giant, usable plot of land, totally ready for the next big thing. Okay, so our city is up and running, the citizens have places to live, but now they need to start using the shared infrastructure, things like roads and bridges. And if our city manager isn't super careful here, this can lead to absolute total gridlock. Let's stick with our city analogy. Imagine there's a narrow one-way bridge that can only hold one car at a time. Now, this bridge could represent any resource that only one program can use at once, like your printer or a specific file you're trying to save to. All right, so here comes our first car, Car A. It gets onto the bridge, it has successfully claimed that resource, and it's holding onto it while it crosses. But, here comes the problem. Car B enters the bridge from the complete opposite direction. Now it's holding its part of the bridge, and it needs the space that Car A is currently occupying to get across. And bam, gridlock. Or, as we call it in computer science, a deadlock. Car A is waiting for Car B to move, and Car B is waiting for Car A to move. Neither one can go anywhere. This is literally what's happening under the hood when one of your apps freezes and you get that dreaded spinning wheel of death. The entire city has just ground to a complete halt. Now, this kind of digital gridlock is actually kind of rare because it can only happen if all four of these specific conditions are met at the same time. The resource has to be exclusive, only one car on the bridge. You need that hold and wait situation. You can't just forcibly kick a car off the bridge. That's no preemption. And finally, you need that circular wait. A waits for B, who waits for A. The OS, our city manager, has all these sophisticated strategies to make sure these four things don't happen together, preventing or breaking deadlocks to keep traffic moving. So far, we've really just been talking about what's happening inside a single computer, right? A single city. But what's so cool is that the exact same principles our city manager uses, well, they don't just apply to one city. They apply on a global scale. You know, the history of computing is really the history of our digital cities growing up and evolving. We started with these giant mainframes. Think of one massive capital city serving everyone. Then came personal computers, which were like individual towns and villages popping up everywhere. Then we connected them all with networks, our digital highways, and that all led us to today, where we have the cloud. So the job of the modern OS has gotten, well, exponentially bigger. It's not just a single city manager anymore. Now it's like it's managing a planet-spanning network of cities, a global metropolis of data centers, services, and apps, all interconnected, all needing their resources scheduled and managed with absolute perfection. I mean, the scale is just, it's mind-boggling. But at the end of the day, it's those fundamental principles we've been talking about, process management, memory management, and avoiding gridlock, that make this almost infinite power and capacity of the cloud possible for every single one of us. So the next time you double-click an icon, maybe just take a half second to appreciate that invisible city manager working tirelessly behind the scenes. It's the true unsung hero that turns a bunch of silicon and wires into the vibrant, living digital world we all depend on. Which leaves us with one big question. As our digital cities keep merging into this massive global cloud, what's the next great challenge for the city manager? How will it have to evolve to handle a world that's getting more complex by the second?